mutually exclusive events. This is addition rule in probability, and we're going to talk about non-mutually exclusive events as well. All right. Definition: two events are mutually exclusive if they cannot happen at the same time. The very basic and easy example that I usually give is this one. When I roll a die, I'm going to get one outcome. Only one number is going to show up. When I roll a die, the probability of getting 1 is only based on the 1 over 6. I cannot get, when I roll a die, get a 2 or a 3 at the same time. So just one number comes in. And that is mutually exclusive. Actually, let me actually do a Venn diagram. So let's suppose we have this set, okay? And we have two sets, sets A and set B. Okay, and the way we write it, we say that on a mutually exclusive events, this notation is upside down U, but it actually is a set notation. If this is an empty set, that means they do not intersect. You do not see A, B, the two circles intersect. Okay, so they don't look like this. There is no intersection here, right? There's no commonality between the two. Probability of A and B, or intersection B, this symbol means intersection. Okay, so probability of A intersect B, the way we write it is probability of A and B will end up being 0 because of that. There is no commonality there, but we know that the probability of A or B is equal to probability of A plus probability of B. Okay, so we just add the two probabilities together because they are mutually exclusive. Simple as that. Let's look at an example here. There are 13 athletes, which 6 play only football and 7 only play basketball. What is the probability of a randomly selected athlete plays one or other sport? Now notice that no athlete here plays both sports, so it's very simple. So we can just say probability of football or basketball is equal to probability of playing football, that athlete playing football, plus probability of that athlete plays basketball. Okay, the probability of the athlete plays football, there are 13 athletes, 6 of them, so that will be 6 over 13 plus, and the probability of athlete plays basketball will be 7 out of 13. Simple as that. And then you just add them all up, you get 13 out of 13, which is equal to 1, which means 100%. Well, that makes sense, right? Because when you choose one athlete out of the 13, guarantees that that athlete will play one of the sports, right? For sure it will be. All right, so that's the example of that. They are mutually exclusive. They're not going to affect each other, influence each other, and they have no commonality in between. So mutually exclusive, the same way as the Venn diagram is explaining it. Okay, now let's look at non-mutually exclusive. And non-mutually exclusive, let's go back to the set again. I'm going to draw the set. So in this case, when we have not mutually exclusive events, what we have is that A intersect B is not 0. Okay, so that means there is a shared area between the two events. That means they are not mutually exclusive and they share some commonalities. So they can both happen at the same time. Okay, unlike the other example. And the way we write it is we write it as probability of A intersect B, intersection B, or probability of A and B, that is not equal to 0 because we will have some values. So, and then the way we write it, for the OR, probability of A or B will be probability of A plus probability of B. Okay, so this is very important to pay attention to. Okay, so probability of A or B will be, okay, we have A is happening, B is happening, but then we have to take away the probability that is happening for both of them would be probability of A and B. Okay, so that is the expression for the events, two events that are not mutually exclusive. And let's do an example to explain what that is. It's very straightforward. You just have to make sure you don't double count the shared area when you're dealing with the probability of A or B. All right? So let's look at this question now. A card is drawn from a deck of 52 cards. Find the probability that the card is drawn is a 2 or a heart. Okay, so let's write it up. So we have probability of 2 or heart is equal to probability of 2 plus probability of getting a heart minus probability of 2 of heart. And in that case will end up being the AND. This is the AND piece, right? In the formula up here. Okay, so let's go ahead and do the math on that one. It's very simple. How many 2's do we have? We have 4 2's, so that would be 4 out of 52. That's the total sample space, 52 cards. We have it right there. Plus probability of a heart. How many hearts do we have? This sweet heart is 13 of them, right? So it would be 13 out of 52. And then minus, what is the probability of 2 of a heart? Well, 2 of heart is a very specific thing. So that's 1 out of 52 cards will be that. You do the math on that one, you'll end up getting 4/13. That's the probability in fraction. You can divide that and get a decimal expansion or put it in a percentage, and that is okay. All right, so make sure you go through this lesson again. Talks about mutually exclusive and non-mutually exclusive events and how they are related, and use the Venn diagram to help you understand. All right, check out the next video in this series, probability. I'm going to continue with that. Until next time.